Hello everyone. We continue with trigonometric ratios for any angle between 0 degree and 360 degree. So this is video 2. On video 1, we looked at cast rule. And cast rule tells us which trigonometric ratios are positive in which quadrant. And we said that when we are writing a cast, we always start from quadrant 4 and go to quadrant 1, then go to quadrant 2, and finally quadrant 4. So again, this tells us that in quadrant 4, only cosine ratio is positive. In quadrant 1, all trigonometric ratios are positive. In quadrant 2, only sine ratio is positive. And in quadrant 3, only tangent ratio is positive. So when we look at this diagram, it is talking about reference triangles. So what's a reference triangle? So on the first video, I gave you an example and said that 30 degree, 150 degree, 210 degree, and 330 degree are related because their related acute angle is the same. So actually, if we use the terminal arm of the angle and the x-axis, we can build right angle triangles. Okay, so these right angle triangles are called reference triangle. So for 30 degree, it's going to be here. So for 150 degree, again, we are going to use the terminal arm and the closest x-axis to draw the reference triangle. For 210, it is in quadrant 3. So reference triangle again is going to be, we are going to use terminal arm and x-axis to build a triangle. And for 330, so we are going to use terminal arm and x-axis to build a reference triangle. All those 4 triangles, as you see, will involve related acute angle. So if I put all those 4 triangles together in the same Cartesian plane, so from the first quadrant I get this, second quadrant I get this, third quadrant I will get this, and fourth quadrant I will get this. And all of them for the specific angle will have related angle 30 degree. Okay, so this is called bow tie. So when you're making your reference triangle, you always use the terminal arm and the x-axis and never use the y-axis. Okay, so therefore you need to remember remember that your triangle should be part of this bow tie. So principal angle is an angle between 0 and 360 degree. And related acute angle, we call it beta, is between 0 and 90 degree. So we are going to talk about coterminal angles on the third example. So let's look at example 2. It is asking us to find the exact values of each trigonometric ratio. And we are going to do this without using a calculator. So those are all related to special angles. Therefore, we are going to use special triangles. Those special triangles, we learned it in the last lesson, and it must be in your memory by now. So I put them here so that you can visualize as we solve these questions. So now we are going to calculate sine 30. So the first thing we should do is sketch the angle. So rotate it. So x, y. So our initial arm is on the x-axis. So this is a positive angle. We go counterclockwise. It's an acute angle. We know that the terminal arm will be located in the first quadrant. So that is 30 degree. So that is theta. And also related acute angle for this angle again is going to be the angle between the terminal arm and the x-axis. So for this question, related acute angle is also 30 degree. Okay, so now we are going to look at the sine ratio of 30 degree, and again using cast, we know that the trigonometric ratios of all angles are positive in the first quadrant. So we know that sine 30 degree is going to be positive. So looking at this special triangle, sine 30 is opposite over hypotenuse. So that's going to be 1 over 2. Let's look at B, cosine 240. First step, again, rotating the angle. So x-axis, y-axis. So we are doing positive 240. So positive 90, 180. If I go that much, that would be 270. So then the terminal arm should be around here. So that gives me 240 degree. Okay, so I cannot directly calculate cosine 240 without using a calculator. Therefore, I will get help from the related acute angle. Then the second step after rotating the angle should be finding the related acute angle. And that is going to be, again, the angle between the terminal arm and the closest x-axis. So that is our beta. So if this is 240, and again, this much is 180 degree. If I subtract 180 from 240, I can get beta here. So beta is theta minus 180, or 240 minus 180. So that gives us beta equals 60 degree. So now I know that cosine, so 240 and 60 degree are related. So cosine 240 is going to have same numerical value as cosine 60. The only thing I need to decide after this point is that the sine of cosine 240. Okay, so first we're going to write cosine 60. So cosine 60 using the special triangle is adjacent over hypotenuse. So that gives us 1 over 2. So I know that cosine 240 and cosine 60 will have the same number. But I need to decide if I need to put a negative sign here. Okay, if this is going to be negative or positive. So to decide that, now we're going to use cast. We always start writing cast from quadrant 4. Okay, and we see that quadrant 3, the only positive ratio is tangent. So tangent is positive, but cosine and sine is negative. So that tells us that then cosine 240 must be negative. So then cosine 240 is negative 1 over 2. Let's look at another example. Tangent 315 degree. Again, first step, rotate the angle. So 90, 180, 270. So that would be 360. So looks like the terminal arm is going to be located in quadrant 4. So this is 315 degree. Second step, find beta. So beta is the angle between the terminal arm and closest x-axis again. So that is our beta. So if we made one full rotation, that would be 360. Okay, so it looks like I need to take the difference between 360 and 315 to calculate the beta. So 360 minus 315. And that gives us 45 degree. So that is step 2. Step 3 is finding the ratio. So this is step 1, drawing, finding related acute angle, step 2. Step 3, we are going to find the ratio for the related acute angle, tangent 45. So to do that, we are going to use our special triangles. Tangent 45 is opposite over adjacent. 1 over 1 gives you 1. So that is 1. So now we know that 350 and 45 degrees are related. So tangent 315 will have 1 as a numerical value. But again, you need to decide if you need to leave it as positive value, or if you need to put negative value here. So for that, we are going to use cast. So step 4, writing cast. Okay, so in quadrant 4, we see that only cosine is positive. So therefore, tangent must be negative. So we put negative sign here. Okay, let's look at another example. Secant 330 degree. So this is, first of all, you have to write the related primary ratio to be able to calculate secant 330. Okay, so that is not primary ratio. So secant is related to cos. Okay, first I am going to find cosine 330, and then I'm going to take reciprocal of it to calculate secant 330. Again, step 1, sketch the angle. So 90, 180, 270, and 330. Step 2, find beta. So beta here is going to be again 360 minus 330. So beta is 360 minus 330. So that gives us 30 degree. Step 3, find the ratio of the related acute angle. So we are going to find cosine 30 degree. So use a special triangle to get it. Cosine, so 30 degrees here, adjacent over hypotenuse. So looks like this is root 3 over 2. And the last, so step 4, so write the cast. Okay, so we know that again 330 degree and 30 degree are related. Cosine 330 will have the same numerical value, root 3 over 2. But now you need to decide if you need to put a positive or negative sign here. Okay, so now using the cast, we are in quadrant 4. We see that only cosine is positive. Okay, so we have cosine, so means cosine 330 is positive root 3 over 2. Okay, after we get cosine 330, now we can look at secant 330. Secant 330 is 1 over cosine 330, so that gives me 2 over root 3. But I need to rationalize it, so I'm going to multiply top and bottom by root 3 over root 3. So secant 330 gives us 2 root 3 over 3. Okay. So let's look at part E. Cosecant 300. Again, I need to write primary trig ratio for this first. So sine 300, okay, because cosecant 300 is 1 over sine 300. So let's get sine 300 first. Step 1, sketch the angle. So start from here, positive 90, 180, 270, so 300 is somewhere here. So terminal arm is located in quadrant 4, so positive 300. Step 2, find angle beta. So beta, again, is the angle between the terminal arm and the x-axis. So to get beta, we need to subtract 300 from 360. So that gives us 60 degree. Step 3, calculate the ratio for the related acute angle. So we need to find sine 60. Again, we're going to use our special triangle. Sine 60 is root 3 over 2. So then we know that sine 300 will have numerical value of root 3 over 2. The only thing we need to decide if we need to put positive or negative sign here. So now we are going to use cast, and that is your step 4. Okay, so we are in quadrant 4. In quadrant 4, only cosine is positive, so tangent and sine negative. So we have sine, so that must be negative. After you get sine 300, now you can get cosecant 300. So 1 over negative root 3 over 2 gives you negative 2 over root 3. Again, you have to rationalize the denominator, multiply top and bottom by root 3. So that gives us then, so cosecant 300 negative 2 root 3 over 3. Let's look at next example. Cotangent 150. So again, write the related primary ratio first. So we have to get tangent 150 first. So step 1, sketch the angle. So 90, 180, so 150 should be in second quadrant. Step 2, find related acute angle. So in this case, so we can get beta by subtracting 150 from 180. So beta is 180 minus 150. So that is 30 degrees. Step 3, find the trig ratios for the related acute angle. So tangent 30. We can use special triangle here. Tangent 30 is opposite over adjacent, 1 over root 3. So tangent 150, we know that we'll have a numerical value of 1 over root 3. Again, let's decide if we need to put positive sign or negative sign here. So we are in quadrant 2, right cast. In quadrant 2, only sine is positive, tangent must be negative. So we have negative 1 over root 3. Cotangent 150 is 1 over tangent 150. So then we just flip this and we get negative root 3 for cotangent 150. Now we have two negative angles here. Okay, H is sine negative 150. So step 1, sketch the angle. So we go, since it is a negative angle, we need to go clockwise direction. So this would be negative 90, this would be negative 180. So negative 150 somewhere here. Okay, so that is negative 150 degree. Step 2, find angle beta. Okay, so this is 180, that is 150, subtract them. So you get beta being 30 degree. Okay, angle beta is an acute angle and it's always a positive angle. So that is the kind of distance in terms of angle, of course, between the terminal arm and positive x-axis. So it is positive 30 degree. Step 3, find the ratio for the related acute angle. So we need to find sine 30. So we already know it is 1 over 2. Then step 4, so we know that sine negative 150 and sine 30 now will have the same numerical value because they have the same related acute angle. So we know that we are going to have 1 over 2. But now we need to decide if we should put negative or positive value here. Okay, so again, to do that, that is step 4, right cast. We are in quadrant 3. In quadrant 3, looks like tangent is positive, so sine must be negative. Next example, we have cosine negative 225. Again, step 1, sketch the angle. It's a negative angle. We go clockwise. Negative 90, negative 180. So that would be negative 270. So looks like we are going to end up in quadrant 2. So that is negative 225. Step 2, find angle beta. So this is 225 and this piece is 180. So subtract 180 from 225. So you get 45 degree. Step 3, find the ratio for the related acute angle. So we need to find cosine 45 using special triangles. So let's take this 45 degree adjacent over hypotenuse 1 over root 2 or root 2 over 2. Okay, so now we know that cosine negative 225 and cosine 45, they have the same related acute angle. So cosine negative 225 will have a numerical value of root 2 over 2. Again, decide if you need to put positive or negative sign here. So right cast, this is the final step in quadrant 2. So we see that only sine is positive, so cosine must be negative. Okay, so we will continue with example 3 on the next